close in. I can see it's good.
Got it?
Yeah.
As it gets warmer, it will fizz even more.
You can explain to people what we're doing.
This is zinc going into AQUA REIGIA. Precious metals are plating onto the zinc. Zinc is going into solution. Precious metals coming out of solution and turning black.
And you see the black growing on the, and then falling down.
It's also good to stir while you do this.
See the black on the edges?
Yep. And the zinc is gone.
Yeah.
I'm going to check the temperature. 54.
That's centigrade?
Mm-hmm. No, Fahrenheit.
Oh. That's pretty
Put some
cool
more
on the
in.
bond here.
Even more reactive.
Oh yeah, what's all that?
See that?
Yeah. Now what is all that?
That was zinc. Zinc shavings.
Oh, is that what those are?
Zinc has already been done once and the base metals have been removed. So this should be nothing but noble metals. Silver up or silver down. And the zinc is gone.
Yeah.
This probably still has nitric in it. So, zinc should be driving off the nitric.
It's turning clearer again. It's getting nice and clear now. Yeah, it turned nice and clear again.
Yep, pretty good fizz with SULFAMIC.
Yeah, you got that.
Which means there's too much nitric in there.
Oh, look at the bottom.
Yep.
It's fizzing, making it milky. I'm not the same one. Oh, here we go. Are the fumes nasty? I'm not smelling anything back here.
I'm not sticking my nose in there to find out.
You're going to find out. Right? Oh, look at the bottom.
Yep. Looks like there's SULFAMIC sitting on the bottom, not doing anything.
Yeah, I think it's...
There, much better.
Now what was that we added?
Zinc.
Zinc.
That's after driving off the residual nitric.
There you go. And that was more zinc.
Zinc.
Now what is the zinc doing?
Zinc is going into solution. All metals on the reactivity series below zinc are coming back out of solution. But since this is the second time we've done this, we've already, with hydrochloric, rinsed out the base metals, which means all the metals between zinc and hydrogen have been removed. The metals that are left start with silver, gold, platinum, rhodium, palladium, and a couple of others. And in theory, everything that's left in here is sitting in hydrochloric acid and not going back into solution, which means it should all be noble metals, silver up. You can see them there. But the liquid is still green, which means we should probably continue until it's not green anymore. When the iron was in it, there was lots of red. The liquid was red.
And the fumes coming off of that aren't so great either.
And this is how they made hydrogen gas in the Civil War. This is exactly how. Quite a few carboys, I forgot how many, 14 carboys of hydrochloric acid and a couple of tons of zinc, and mix them together and use canvas tubing to push hydrogen gas into a balloon, and
up you go.
And in the Civil War, if you wanted to, you could sign up to be in the balloon force. Mainly spotters with telescopes.
And mix dangerous flammable chemicals.
Directing artillery and reporting on enemy movements.
Yeah.
And we're not at 70 anymore. Nope.
101. Oh yeah, that reaction.
Now watching the temperature, because I really don't want to boil over.
Yeah.
You see, there's no safety pot here because I want everybody to be able to see it.
Yeah.
But you see, there's a pile of
zinc on the bottom.
precious metal sand in the middle, and it is boiling a little bit. Still some zinc in it. So I really don't want to go over 150 degrees.
Whoa, okay.
And the zinc is still turning black, which means stuff is still
Coming out.
I won't take this all the way.
Minor temperature
We'll
now.
drive it out.
What's temperature now?
108.
You went up a little bit.
Meaning
Going about 7, 8 degrees every
7,
time
8
you
degrees every time I do this. It's a single displacement, and when the zinc goes into solution, other metals come out of solution and replace it. And since it's still sitting in acid, base metals are going back into solution at the same time. This is driving out base metals and the noble metals all at the same time. And the acid is driving the base metals back into solution, leaving behind
the nobles.
noble metals. Which if you get up here close, you can see it.
Oh yeah, I can see them. I'm zoomed way in. I can see real good.
A little bit of a sandstorm.
Oh yeah, there's like black stuff on the bottom. Oh yeah, I got it real good.
Now, in order to let, because this is doing that second reaction, putting things back into solution, we'll let it set for an hour before we draw off the acid, and then start doing water,
Rinses.
ammonia, boiling washes. And we've done that to this before to get the base metals out, and we'll do it again to get any trash metals out. Now that looks like a lot. It's very little. I'd be surprised if that was more than a BB.
Yeah, it's all fluffy and
That is very porous because the acid's getting in there and driving out any base metals that carried through from the last time. Let's check and see if it's turning black. Yep, still plating.
oh yeah.
But that could very well be base metals plating.
No.
How do you know when the reaction's done? When it's time to stop? I have no idea.
Yeah, take the temperature.
I'm gonna clear this up until there's almost no green left,
Oh, who knows how far you have to go for that?
until the reaction is almost stopped, or until I run out of zinc.
Take your temperature each time. There's a lot of acid in this, Joe, huh?
It's all acid.
Well, that's really going. No, take your temperature. That's really. A lot of vapor coming off of it too.
It's hydrogen. No light any matches.
Yeah,
We're in
100.
a pretty big room, so there's a lot
Yeah.
of hydrogen. They're up to 145
No
now.
sparks or anything.
As the temperature go up, the reaction
It
gets,
gets faster. I noticed every time when you add it, it's fizzing. It's more violent. You need to add less.
It's like a snow globe of pepper.
Yeah.
Now, if we let this sit,
Oh, see, it instantly
this
turned
stuff
clear.
the metals are going to foam,
Did you see it just suddenly settle? See how it just
Yeah.
suddenly turned clear?
and because I'm stirring it quite a bit, it's causing it to break down and not become a sponge. If you
Yeah.
don't stir it, this stuff will become a pretty big sponge. It'll even push up out of the
You were telling me
liquid.
it filled the whole beaker last time you did this.
Yep. It will fill the beaker with a sponge. So watch the color.
Yeah, now it's getting changing. It's bluer. You see that?
And this is a cleanup drop. It's already been cleaned. Now we're dropping it again.
Turn green again.
We're going to take this powder. This is going to reduce to almost nothing as a powder, not even a spoonful.
Yeah.
Then we're going to put that on an XRF
And see what we got.
find out about all the precious metals
See what we got.
that were driven out. Find out if the theory is correct that this does drive
See if
out.
it works.
Confirm that it
Yeah.
drives
There's a
out.
big lump sitting on top there too.
A little bit of entrained gas.
Hydrogen gas it's mixing with it. Yeah.
And it will cause things to float. And that stuff is very spongy, and you can see how
It's just yeah.
it acts like gold. It will clump up. This will all become one clump. See how it's clumping?
Yeah. Oh, I got a good picture of you.
As the base metals are coming out,
It's red there in there
it
too.
starts to clump up even more and more. It becomes a sponge.
Can you see on my screen there? See?
You can tell just a little bit of action. Back up a little bit. There you go. See, I barely stirred that.
Yeah, it looks like cloud.
Excellent video, by the way. It's really good. We're still green, so we're going to add some more.
Okay, and get out of the way. No sparks, please.
No smoking. See, the acid is still strong, and look at that.
See how it's turning blue there when you do that?
I put the zinc, not yet. In theory, no base metal should have made it this far in the process.
Oh yeah.
In theory, no base metal should have made it to this
Yeah.
point, because this is the second time. Base metals have been washed out, acid washed out. There should be no base metals in this.
It's in it.
Now we'll break up the sponge,
Yeah.
get some motion going, and watch what happens. Kind of the cat turd phenomena you get with other dropping with other methods.
Forms long, stringy lumps.
Very much like cat turds. The most beautiful cat turds in the world. Well, that's what we're going to name the video.
Oh, okay.
Zinc cat turds.
Yeah, okay.
Dropping with zinc, making cat turds, homemade cat turds. There you go.
Yeah.
Okay, check the color,
It's a lot lighter green than it was before.
and we'll check the temperature. Remember, I want to stay about 150.
Yeah, well, that's where we're at.
149.3.
3. Yeah. Yeah, it's you're there. Now, do you want to let it cool before you add more? Or,
Okay. Now, we'll do one more and let it cool. See, the reaction was a little less that time
Yeah,
because our color's
it's a lot lighter green.
quite a bit less. You see all
just about there. Let's settle and see what the color turns. A little green still.
I'm pretty sure we're getting near the end.
Oh yeah, it's a much paler green.
And we're getting much more.
Yeah, there's a lot more black on it.
Much more stuff. You see the big sponge.
Yeah.
That will reduce, once it's boiled and clean, that will reduce to be a very thin film on the bottom of the speaker.
Yeah, it's all.
Not so much the volume I'm concerned about as what is in it. Is there going to be rhodium in there? Is there going to be palladium, platinum?
Gold.
We already know there's going to be gold. Should be, mathematically, there should be maybe a quarter to a half a gram of gold in this.
What about rhodium? Huh?
The other metals, we don't know. We know they are there, don't know how much. You're going to find out if it's worth, hit this with an XRF. There should be no other metals in there.
Other than nobles. Yeah. Or very few. Maybe trace amounts of stuff, but
Yes.
there should be nothing. It's every time you do that, it's less green. Green's almost gone.
It's a yellow now.
Yeah.
The green is pretty much gone. Now we're down to a little bit of yellow.
It's kind of.
And the reaction takes a little bit
very
longer.
pale yellow green.
We're going to watch the surface of this to see if it,
Yeah, I got
if
it.
it turns black. Plenty of acid still.
Yeah. It's all milky now. Notice that. Got milky white that time.
I'm not a chemist. I'm not a metallurgist.
Yeah. But that time it's all milky white.
And it's got a lot of gas entrained in it right now, which is coming out. 151.
Yeah, I only went up by half a degree maybe. You can see those things are putting out gas because they're like moving around or like propelled. See them?
There's our wad we just put in. It's still
dissolving. Yeah, there it is. Oh yeah, see, it's got. Is that clean metal I saw in there? Huh? Yeah, it's not.
Looks like it's still clean right there.
Yeah, I can see it. Yeah, like I said, it's clean metal.
It's still clean.
Yeah, so
So
we're
we
done.
may be near at the end.
Oh, look at the white milky stuff coming off of it.
See
with-
that? Still
That'll
got some clean, still boiling.
Yeah, you can see it really good in the video here. Yeah.
So I think we're very close to the end.
Look at the hydrogen gas coming off of it. You can really see it. Well, you can see it a second ago.
Of course, now that I stir it.
It's gone, yeah, but you'll see.
So I'm going to do one more, and we're done.
Yeah.
Give this a good stir. Because maybe in that zone it was metal free.
All mixed up.
How much have I put in? Zinc?
Yeah, that's a good question. How much?
Maybe half an ounce, not even half an ounce.
Yeah. Just shavings.
Between half an ounce to an ounce. Now I'm going to put in
It's still a tiny bit yellowish green.
about 1-2 fingers worth. Still got acid.
Yeah. Oh, that turned black.
It's still acidic. You haven't seen me do a single pH check.
No, you don't need to when you add method and it foams. You know it's acid.
Yeah. I've not done a single pH check on all of this. It's acid.
Yeah,
It's
it's
below
definitely.
1. That's all I need to know.
Yeah, you don't need to know exactly. Yeah. You stood out. You got a big lump right at the top there. So full of gas. There you go.
Let's break all that up. Break that sponge up. Don't worry, it'll come back. It's enough acid in there to take any base metal and put it back into liquid.
And now the solution is more gray.
It's not
flash red. And
because we put the sulfamic in it. It's not AQUA REIGIA anymore.
So the precious metals will drop out, won't dissolve.
We will still change this out with fresh hydrochloric. Give it a boil. Probably lose a little bit. Shouldn't lose any because we've already cleaned this once. But now
I think it's gone. I think we're done.
Still boiling in the center.
Yeah, I can see the gases coming off of it. It's still reacting. See it right there?
Yep. Went from green to kind of a light yellow.
Yeah.
I suspect it's trying to be red because there may be some iron that got through. That made it through to this part of the process. But we're going to let this sit, and if there's iron in that sponge, this acid will take it out.
Well, what's still reacting? Would that be the base metals going
zinc.
into solution? Back in.
That could be base metals going back into solution.
Yeah, releasing the gas as they do. It's just coming out of the middle there. It's slowed down a little bit. It's still going though. It's slowed down. It's almost stopped. That's pretty good. Okay. Good.
Now we're going to look down at the very top and
move the rod out of the way.
Show the whole glass. You're zoomed in way too far. There.
Yeah, I just want to see See it? Still bubbling.
Good picture. Okay.
Oh, you can smell the... Yeah, it did turn red. And brown.
Reddish brown.
Because the pH just shot up on it. You did that.
Well, let's check it.
Huh?
Now that I put a bunch of water in it.
Start to wind up around the blade, huh? Yeah, you build up on there pretty good. Is it melting?
Yeah, I'm pushing it too hard.
You get a cold ball. Well, that's not a ball, is it? melting it? I smell it burning.
Not yet. Everything's pretty hot.
Oh, this thing. Still not boiling yet. I think you're melting it now.
With an Allstate agent, you get a local expert and help finding the best coverage for you. And because they live in your community.
Okay.
These look a little different.
That melted. The tip of your drill is all covered with melted zinc. Got to remelt those balls, huh? Into something.
Yep.
Should be easy. Easier than lead, wouldn't it? Isn't it? You just melt those on the stove, can't you?
Yep. That's your job.
Oh.
Get you a little tiny fire pan and you'll weld a piece of rebar to the handle. And you're going to pour bars, little tiny bars, and I can drill them.
Are these those lead bar things?